I'm audible, right? So let me share my screen first. Hmm, hmm. So we had three problems for today. So let's start with the very basic one, right? Uh, yeah. So let's start with the very basic one, which was even, height, odd. So in this one, you had some elements, and you have to find the minimum number of operations that are required to make the number of even elements equal to number of odd elements. So how can we do this? Right. So the very first thing is, right, if your n is odd, then the answer is impossible, right?
Zebronics for life. Okay, ma'am.
Akash, can you mute yourself? Yeah. So if n is odd, then the answer is impossible. So that is the very first thing, right? So if the answer is impossible, you just print out -1. Otherwise, if n is even, right? If n is even, then your odd elements must be equal to n by 2. Similarly, your even elements also be must equal to n by 2. So what you can do is you can count the number of even elements or odd elements. So count the number of let's say odd elements. Then your answer is just the absolute difference between the number of odd elements that you have and n by 2. So it will be n by 2 minus count, right? So that is the entire solution. If you guys want to code it out, I can code it out as well. But yeah, I don't think there's much to code. So like that is the entire solution, right? I will send you guys the code later in the channel as well. I don't think it is that hard. So anybody has a doubt in this? Otherwise, we can move on to the next one. All right. Yeah. So let's move on to the second one. That is again 25. So in this, like we have been given some number n, and you basically have to print. Yeah, Akash, I will share the code in the channel later. Like I don't think the code is that hard in this one. Right. Yeah. So we have a single integer n, and basically you have to find 5b power n. Right. So this is just some observation. So like if you go to OES, right? So 5 the power 1 is 5, 5 the power 2 is 25, 5 the power 3 is 125, into again 5, it will be how much? It will be 625, I think. Right? So if you look this up, right, so this is the expression for 5 to the power n. And if I maximize this, you can see that like every 5 to the power n is ending in a 25. Right? 5, 6, 2, 5, 25, 25, 25, 25, 25, 25. Right? So like any 5 to the power something will always end in a 25. So like you don't need to look for anything here. The answer will always be 25. So just print 25 and that's it. So then we have this one, theater scale. This is a kind of a okay problem. So in this problem, we basically have been given a theater of size m cross n, right? So let's say this is your length m, and then we have some height, right? And we have a height of, let's say, n, and a width of n. Also, we have been given squares of size a cross a, and like you have to find like you have to find the number of squares that are required to cover the entire park. And like you have to place. So if there was any other number other than 5, how do we approach it? Like then you can find the answer mod 100, right? So like when you do binary exponentiation, currently you find answer mod something 1 in 9 plus 7. But like if you have to find the last two numbers, you can just find the power under a mod, right? Under a mod of 100, and that will give you the answer. Yeah, so like we have squares of a cross a, and we have to use them to cover this entire grid. So what you can do is, first of all, you can try to cover this entire length, right? So you will, let's say you place a square here, right? The length of this will be a. Similarly, you will again place a square here. Again, the length of this will be a, right? Again, you place a square here, and again, the length of that will be a. Right. Similarly, you will keep placing squares until you reach or until you exceed with him. So like can anybody tell me the number of squares that will be required here? The number of squares that will be required to complete length m. Yeah. So it will be just ceil of m by a, right? And similarly, this will be squares required to fill width. And due to symmetry, I can say that the number of squares that are required, to fill your height will be equal to ceiling of n by a. And like when we find ceil, like there is a ceil function in C++, but we don't really use that, right? Because like when you are dealing with ceil, it means that you have a floating number, and like floating numbers sometimes can misbehave, right? Due to like because there is only so much space that you can hold, so sometimes maybe ceil of floating numbers can come out to be wrong. So like but we do to avoid that is a simple trick. So to find a ceil of any number, let's say a over b, this is just equivalent to saying find the answer of a plus, or you can say if you have to find ceil of a by b, it is just equivalent to finding ceil of a plus b minus 1 over b, right? It's not ceil, this is just normal division, right? You guys can try to see this out, right? So like this is a very well-known used formula as well, right? So like if you have to find ceil of a by b, you can just write it as a plus b minus 1 over b. So if we have to find ceil of m by a, I can just say that this will just be equal to a plus m plus a minus 1 over a, right? Similarly, here I can say that the answer will be n plus a minus 1 over a. So let's say this is some number x and this is some number y. Then the answer will be just x into y, right? That will be the answer. But what floor? Like a floor is the basic behavior, right? So like if you divide any two numbers, the answer is always floored by default. So like we don't have to do anything about floor. So like I can try to code these questions out for you quickly before you guys go to your PCD. Mm, Solution. So what do we have here? We have n and Mendy. Oops. If we divide two integers, are we going to get float? Uh, like if you have to find ceil, you have to find float, right? Because like for example, if you have let's say 6 and 4, right? So if you do 6 by 4 and if you are doing integer division, you will get 1 point this will be 1.5, right? I think it will get flowed, this will get flowed to 1, right? And now if you try to find ceil of 1, it will be 1, right? So like it will not work. So like if you have to find ceil of a by b, where a and b are integers, then you have to typecast them into floats first. Typecast them into floats. Now it will be ceil of 1.5, and it can go up to 2. Now, why don't I recommend to use ceil is because let's say you have ceil of a number 2.00000000000, right? This is the number that we want to find the ceil of. But the thing is, your computer only has so much space, so maybe there is not so much space to handle this one, right? So this one will be dropped off, and like when you try to find the ceil of this will come out to be 2 only. But originally we had a 1 here, and ceil of this should have been 3, right? So like that is how floating points can affect your ceil. So that's why we don't recommend to use C. Instead, use this trick that I told you. Right? So we take in n and a, then your like x is just equal to n plus a minus 1 over a. Your y is just equal to n plus a minus 1 over a. And your answer is just x into. We have a single test case, so we don't need this. Right? So we get the answer equal to 4. I can try to sum this as well, but I will not. And then we had this problem. We can also do this. So let's solve this one quickly as well for you guys. You guys don't need the code for this one, right? You just have to print out 25 and that is it. So I will just code this one out for you guys. So we have some n numbers. We take in n numbers. This is fine. So like if your n is odd, right? Just return false. And like when you get false here, just print out minus. Just print out minus. Yeah, that is it. Otherwise, you have to count. Let's say needed is equal to n by 2, and the count is equal to 0. We count so long as I is equal to 0, I is less than n. Count plus equal to v of I and 1, right? So if the number is odd, increment the count. Then your answer is just uh, add the absolute difference between needed and count. So let's copy the input for this as well. Right, so we get 0, 2, and minus 1, and that was the answer. Right, yeah, so that is it. 5 the power 2 mod 10 should not give 4. Like there is something wrong with your implementation if you are getting that. Yeah, so like anybody has any doubts, or otherwise we can end the meet and you guys can join your PCD. I don't see any, so I will assume you guys are all good. So thank you for joining in, and bye bye.